Welcome to Bedtime Astronomy. Explore the wonders of the cosmos with our soothing Bedtime Astronomy podcast. Each episode offers a gentle journey through the stars, planets, and beyond, perfect for unwinding after a long day. Let's travel through the mysteries of the universe as you drift off into a peaceful slumber under the night sky. This week in astronomy: early dark energy, Polaris down mission, and primordial black holes. Early dark energy, a new force shaping the universe. A groundbreaking study by MIT physicists proposes that a mysterious force known as early dark energy could provide a solution to two of the most perplexing puzzles in cosmology. This elusive energy, which may have been present only in the universe's early stages, could explain both the Hubble tension and the unexpected abundance of bright galaxies observed in the early universe. The Hubble tension refers to a discrepancy in measurements of the universe's expansion rate. While one set of measurements suggests a faster expansion, another indicates a slower pace. This inconsistency has puzzled scientists for years. The MIT team's research suggests that early dark energy, by accelerating the universe's expansion during its early stages, could resolve this tension. In addition to the Hubble tension, the study also addresses the puzzling observation of numerous bright galaxies in the early universe. According to standard cosmological models, these galaxies should have been less abundant at that time. However, recent observations by NASA's James Webb Space Telescope, JWST, have revealed a surprising number of such galaxies. The MIT researchers proposed that early dark energy could explain this discrepancy. By influencing the formation of dark matter halos, which serve as the foundations for galaxies, early dark energy could have accelerated the formation of these galaxies, leading to the observed abundance. The study's findings offer a potential unified solution to two major challenges in cosmology. If further observations confirm the existence of early dark energy, it could significantly advance our understanding of the universe's evolution. The discovery of early dark energy could have profound implications for our understanding of the universe. It could provide insights into the nature of dark energy itself, a mysterious force that is thought to be driving the universe's current expansion. Additionally, early dark energy could shed light on the early stages of the universe, a period that remains largely shrouded in mystery. Furthermore, the existence of early dark energy could have implications for the formation of structures in the universe, such as galaxies and clusters of galaxies. By altering the conditions in the early universe, early dark energy could have influenced the way these structures formed and evolved. The MIT team's study provides a compelling case for the existence of early dark energy. However, further research is needed to confirm this hypothesis. Astronomers will need to continue to collect data on the early universe and to develop more sophisticated models of cosmic evolution. If future studies support the existence of early dark energy, it could revolutionize our understanding of the universe. It could provide a missing piece of the puzzle that has eluded scientists for decades. SpaceX's Polaris dawn mission concludes successfully. In a historic feat, billionaire tech entrepreneur Jared Isaacman and his crew returned to Earth on Sunday, September 16, 2024, after a 5-day mission that pushed the boundaries of human space exploration. The SpaceX Dragon capsule splashed down in the Gulf of Mexico near Florida's Dry Tortugas in the pre-dawn darkness, marking the successful conclusion of the Polaris Dawn mission. The crew, consisting of Isaac Mann, 2 SpaceX engineers, and a former Air Force Thunderbird pilot, achieved a significant milestone during the mission. They conducted the first-ever private spacewalk while orbiting nearly 460 miles above Earth, surpassing the altitude of the International Space Station and Hubble Space Telescope. The spacecraft reached a peak altitude of 875 miles, setting a new record since NASA's moonwalkers. Isaac Mann and Sarah Gillis, a SpaceX engineer, became the 264th and 265th individuals to perform a spacewalk, respectively. This groundbreaking achievement marked a departure from previous spacewalks, which were exclusively conducted by professional astronauts. As the Dragon capsule bobbed in the water, Isaac Mann radioed, "We are mission complete." Within an hour, the crew was safely out of the spacecraft, celebrating their success with joy and excitement. The Polaris Dawn mission was a significant step forward for SpaceX and commercial space exploration. It demonstrated the company's capabilities in conducting complex space operations and highlighted the potential for private individuals to contribute to scientific research and technological advancement. Key achievements of the Polaris Dawn mission include: first-ever private spacewalk. The crew successfully conducted a spacewalk while orbiting at a record-breaking altitude. Scientific experiments. The mission involved conducting various scientific experiments to gather data on the effects of spaceflight on the human body and the environment. Technological advancements. The mission tested new technologies and systems that could be used for future space exploration missions, including the development of advanced spacesuits and life support systems. Public outreach. The Polaris Dawn mission generated significant public interest and excitement, inspiring a new generation of space enthusiasts and highlighting the potential of commercial space exploration. MIT physicists proposed primordial black hole flybys could wobble Mars' orbit. In a groundbreaking study, MIT physicists have proposed that if most of the dark matter in the universe consists of microscopic primordial black holes, as suggested in the 1970s, these gravitational dwarfs could be zooming through our solar system at least once per decade. The researchers predict that such a flyby could introduce a detectable wobble into Mars' orbit. This detection could provide strong support for the theory that primordial black holes are a primary source of dark matter throughout the universe. Given decades of precision telemetry, scientists know the distance between Earth and Mars to an accuracy of about 10 centimeters, explains study author David Kaiser, a professor of physics and the Germshausen Professor of the History of Science at MIT. We're taking advantage of this highly instrumented region of space to try and look for a small effect. If we see it, that would count as a real reason to keep pursuing this delightful idea that all of dark matter consists of black holes that were spawned in less than a second after the Big Bang and have been streaming around the universe for 14 billion years. Kaiser and his colleagues published their findings in the journal Physical Review D. The study's co-authors include lead author Tung Tran, Sarah Geller, and Benjamin Lehman. less than 20% of all physical matter is made from visible stuff, such as stars, planets, and everyday objects. The rest is composed of dark matter, a hypothetical form of matter that is invisible across the entire electromagnetic spectrum yet is thought to pervade the universe and exert a gravitational force large enough to affect the motion of stars and galaxies. Physicists have been searching for dark matter for decades, using detectors on Earth to try and spot it and pin down its properties. Most experiments assume that dark matter exists as a form of exotic particle that might scatter and decay into observable particles as it passes through a given experiment. However, these particle-based searches have so far come up empty. In recent years, the possibility that dark matter could exist as microscopic, primordial black holes has gained traction. Unlike the astrophysical black holes that form from the collapse of old stars, primordial black holes would have formed in the first moments following the Big Bang from the collapse of dense pockets of gas. These primordial black holes could be as small as a single atom and as heavy as the largest asteroids, and they could exert a gravitational force that could explain at least a portion of dark matter. The MIT team's study began with a seemingly frivolous question: what would happen if a primordial black hole passed through a human body? Tung Tran performed a quick calculation and found that such a black hole could push a person 20 feet away in a single second. However, the odds of a primordial black hole passing anywhere near a person on Earth are astronomically unlikely. Intrigued by these results, the researchers extended their calculations to estimate how a black hole flyby might affect much larger bodies such as the Earth and the Moon. They found that while the effects on Earth and the Moon were too uncertain to pin to a particular black hole, Mars offered a clearer picture. The researchers simulated various asteroid-massed black holes flying through the solar system and found that a close encounter could set off a wobble or a slight deviation in Mars' orbit. Within a few years of such an encounter, Mars' orbit should shift by about a meter, an incredibly small wobble that could be detected by high-precision instruments monitoring Mars today. If such a wobble were detected, it would be a significant breakthrough in the search for dark matter. However, confirming that the push came from a passing black hole rather than a run-of-the-mill asteroid would require further investigation. The researchers are exploring the possibility of a new collaboration with a group that has extensive expertise simulating many more objects in the solar system to help with this. Matt Kaplan, associate professor of physics at Illinois State University, who was not involved in the study, commented on the research, saying, "It's a very neat test they've proposed, and it could tell us if the closest black hole is closer than we realize." He emphasized that finding a clear signal would depend on the exact path a wandering black hole takes through the solar system. The MIT team's research offers a new and exciting avenue for exploring the nature of dark matter. If their predictions are confirmed, it could lead to a deeper understanding of the universe and the forces that shape it. The prospect of detecting a primordial black hole passing through our solar system is both thrilling and humbling, reminding us of the vast and mysterious nature of the cosmos.